This is the presentation for Groups 3 Simio project. This is the simulation that we developed for the problem statement. As you can see, model entities come into the system. They are then asserted and then brought into a corresponding aisle. This is a 3D layout of the simulation. The model begins at a source where model entities are arrived based on a rate table. This rate table can be seen on the right. This rate table was developed with the data from the problem statement. Once the model entity is created, it is represented as a truck. This truck is randomly assigned to a dock where it is then sorted. These are the docks. Docks were modeled as separators. The shipment truck is destroyed, whereas the pallets are created. The processing time is modeled through a random triangular distribution. The logic used was create new. As I mentioned, the trucks were destroyed. And the new entities created were based on a discrete distribution that was found using the data from the problem statement. Receivers are required at the docks. We have a population of 2 receivers. This was based on the problem statement using the cost analysis of $29 an hour only when they are on work schedule. This was also from the problem statement. They go to docks based on first in, first out, and they are based on a work schedule as well. After the shipments are created in the dock, they are sent to a receiving area. In the problem statement, it states that there is a receiving area for each dock. We made the assumption that this did not matter for the model and consolidated them based on an area. Once it reaches this receiving area, it is assigned a random aisle, as you can see in the bottom right-hand corner. This is also where forklifts pick up the pallets. Forklifts have a population of 4. This is based on the problem statement. They also follow the work schedule. Load time was based on a random uniform distribution. Unload time was also a random uniform distribution. For the cost analysis, we used the 37,000 from the problem statement. We also made the assumption based on the problem statement that said that there was more than enough forklifts, that there would not be any downtime problems, and that the population of 4 was based on the fact that there was that many amount of put array operators available. Aisles were developed as sinks. Each sink represents an aisle. We used an unloading time as a random.uniform distribution. We also ran an experiment on would increasing forklifts and receiver have an impact on time placed on a rack, utilization, and cost. We found through the experimenting, running 20 experimentations of 4 different cases, that all of them did have an impact on time. All of them decreased time higher than of a percentage than they increased the cost, meaning that these would help optimization. These are the CDFs and PDFs we used. You can see the distributions match closely to what we model. For IO assignments, we can see while it's not really a uniform distribution, we found that it was close enough to model as a uniform distribution that we ended up modeling. That's the end of our presentation. This is our actual Simio model for the project. I started the time where we already have a shipment ready to arrive just for the ease of this presentation. If I click run, we see that the delivery truck goes to a random dock. Here a receiver comes to unload it. There is a processing time. Once it comes to a receiving area, a forklift will come, grab that package, and take it to a corresponding aisle. It would then return and grab another pallet. As we mentioned in the PowerPoint, each dock has a random amount of pallets assigned to each truck. Additionally, at each receiving area, we can see that it's randomly assigned an aisle. These aisles so the paths follow along the network, connecting each of the aisles as described in the problem statement. If I switch to the 3D view, you can see that we inputted custom models to represent our items. You can see our doctors are actual doctors. We also included racks to help better simulate what this actual facility would look like. We also added walls around the facility to help better simulate the facility. Switching to an experiment, you can see the experiment that we ran. Stop this. In the actual experiment, we did run it for 20 of each. In this one, I just have up that we did 10. You can see the average time in the system is used for time. Utilization is based on the receiver population's scheduled utilization, and that's followed for forklifts. And then cost was on the cost implemented in the problem statement. Going back to the model, we can see that we have the list of all the aisles that are used for randomly assigning. We also have the rate table for amount of trucks that are coming in. We also have the work schedule that is assigned to each of the workers. That was all based on the problem statement. You can see those times here. So this was a brief overview of our simulation for the project for Group 3. Thank you.